Hello students, today we are going to start the next exercise 1.2 of rational numbers. Yesterday we had a discussion about the properties of rational numbers, okay, where we had a discussion about the properties of addition of rational numbers. We discussed about the first property, that is rational numbers are closed under addition. Then we discussed the commutative property of addition of rational numbers, associative property, additive identity. We discussed zero is the additive identity. Okay. Then also we discussed the additive inverse. Additive inverse is actually if there is a rational number 4 by 3, then minus 4 by 3. If I say there is a rational number 1 upon 9, then minus 1 upon 9 is the additive inverse of that. Okay. So then this is what all we have discussed yesterday and we have understood. Today we are going to continue with the same, and let's proceed with the next operation, that is subtraction of rational numbers. Okay. And here there is only one property that is true, that is rational numbers are closed under subtraction. That is only true. Okay. If p by q and r upon s are two rational numbers, then p by q minus r upon s is also a rational number. That means the difference of the two rational numbers, any two rational number, is always a rational number. Fine. Other than that, if I talk about the commutative and associative property, no, subtraction is not commutative, subtraction is not associative. So only one property to be understood very clearly or to be learned very clearly, that is the difference of two rational number is always a rational number. Okay, all these properties must be written in your register. I have already shown it on the screen. These all properties must be written in your registers. If you have written up to additive inverse, then you must start it today from the subtraction. Okay, you can just write subtraction is not associative, subtraction is not commutative for these two particular. Okay, and these all you must write. Subtraction of rational numbers as it is, properties of subtraction of rational number, the first one as it is. For the second, just write subtraction is not commutative, subtraction is not associative. Why have I written is multiplication of rational numbers? Because first few questions are exactly the same. Multiplication of two rational numbers. Okay, we all know numerator will be multiplied with numerator, denominator will be multiplied by denominator. So these type of questions you'll be doing as homework. Okay, so I'm explaining you that particular concept here only. If we are given two rational numbers, 2 by 3 multiplied by 4 by 5, then what are we supposed to do? We'll multiply the numerator with the numerator and the denominator with the denominator and write it in the form of a rational number. So that's what will be the answer as the of the multiplication of rational numbers, and that is how we get the product of two rational numbers. Okay, now let's proceed. Today we are going to continue and we are going to start with exercise 1.2. For the first question, I'm taking this particular third part. Okay, the question is to subtract minus 7 by 5 from minus 7 upon 9. Firstly, we are going to write the rational numbers in the proper form. Okay, since they are given in the mixed fraction form, so let's write them in the improper fraction form. Now, what do we get? 5 is a 15, 15 1, 16, 16 upon 5 minus 16 upon 5. Okay, this minus sign always is written in the numerator. Okay, even if there is a value with the denominator negative, then it is always that we write the minus sign in the numerator itself. Again, 4 9s are 36, 36 and 7, 36 and 7. Yes, so we are going to get this. Fine. Now, what do we mean by, think for once, what do we mean by subtract this from this? Yes. What does it mean, students? Yes. It means that if we are given two values, say for example, we are given subtract 2 from 7, then we write it as 7 minus 2. That means whatever is written after from, that value will be writing first. Okay, this value will be writing first minus the given value. Okay, so that's what it is. So minus minus becomes plus. Okay, then it is 9 and 5, the LCM is 45. 9 5s are 45, so 43 5s are 250. 5 9s are 45, so we get 16 9s are, and then we'll solve it and we'll get the first. Let's move to the next. Okay, now the in between questions are homework, my dear students. The first question, remaining two parts are homework. Question number 2 is a homework question. Okay, We're taking question number 3 now. It is, what rational number should be added? I hope you are all ready with your book so that you can see the questions also side by side. We're dealing with the third one. Next question. What rational number should be added to minus 5 upon 11 to get minus 7 upon 8? Now to solve it, before I start with the discussion or explanation of this particular solution, what we are supposed to do? Yes, if I say sum of two numbers is 10, one of the number is 2, what's the other number? What do we do? Sum 10 minus the given number 2. So that is how we get 8. So same way, the formula to get the other number is always the sum. We'll write the sum first minus the given number. Okay, so that is what it is. Minus minus plus minus 7 upon 8 plus 5 upon 11. Okay, and this is what it is. 11 and 8, what's the LCM? It's 88. 8 11s are 88, so 11 sevens are 77, minus 77 it becomes, because minus sign is already there, plus 11 8s are 88, so 5 8s are 40, minus 77 plus 40, so what do we get? Yes, we get minus 37 upon 88, so that is what the answer is. Okay, let's move to the next. Now in between there are question number 4, 5 and 6, which are homework questions. Okay, fine students. Question number 7 is what am I taking right now? That is, if x is given as 4 upon 9, y is minus 7 upon 12, z is minus 2 upon 3. Yes, what it becomes? What we are supposed to do in the question, we have to verify x minus bracket open y minus z is not equal to x minus y bracket close minus z. Okay. Now to verify it, what are we taking? We are taking the left hand side first. Okay. So taking the left hand side, x minus bracket open y minus z bracket close. 4 by 9 is x. What is y? Minus 7 upon 12. What is z? Minus 2 upon 3. Let's substitute the values as it is. X at the place of x, x. Y, its place will be substituted the value of y, and at the place of z, the value of z. Minus minus again, students, plus. 12 3, what's the LCM? 12 3 is a 3 and 12. 12 is the LCM, okay? 12 ones are 12, so minus 7 as it is. 3 fours are 12, so 4 twos are 8. 1 upon 12 is what we get. Minus sign is in between. Again 4 by 9 bracket open karoge to it becomes minus 1 upon 12. 9 and 12, what's the LCM? It's 36. So 9 fours are 36, 4 fours are 16. 12 threes are 36, so 9 threes are, sorry, 12 ones are 12, 12 threes are 36, so 3 ones are 3. Okay, 16 minus 3, it is 13 upon 36. This is the left hand side part, the LHS. Okay, you're supposed to solve the RHS, but what is to be taken care of? Yes, the two answers will not be equal. Why, students? Because subtraction of rational number, for that associative property is not true. That is, the rational numbers are not associative under subtraction. We can very clearly understand this by this particular question verification, that the subtraction is not associative for the rational numbers. Okay, so this was the last question for the exercise. Okay, then there is a true false question which you are going to do in your book itself, okay, of the chapter. Now in between I have given you few questions as homework. I'll be discussing this particular, subtract the sum of minus 5 by 7 and minus 8 by 3. So the sum is written, so find out the first sum from the sum, find out the second sum, you write sum 1, then sum 2, okay, and then exactly same as that of question number 1 as we discussed. Subtract this from that. Whatever is written after from, we write that first and then we do the value. What is the formula? Let's recapitulate to find out the other number when sum of two numbers is given. The other number is equal to sum minus the given number. Okay. Now that was all for this exercise 1.2. Your homework will be to write down the properties that I have told you. Exercise 1.2. Classwork questions will be done as classwork. Homework questions all remaining for the exercise. Only the true false part you can do it in your book itself. Okay. Other than that, all are to be done. So thank you for the day, and the homework is very clearly written over here. It is to complete exercise 1.2 with properties in maths 1 only. Students, it should be very clear that in maths 1 only I have told you 1.1, and in maths 1 only you will be doing the exercise 1.2 as well. Okay, thank you.